All right, so a number of us went back this year, and it was just as massive as it's ever been. The logistics are a little bit better than they have been in the past, but I heard various reports from 65,000 attendees to maybe 85,000. It certainly felt like a lot. When you go to reInvent, there are over 3,000 sessions. They're now sprawled across multiple hotels. There's a lot to take in. I had a placeholder here, 300 plus announcements. Feels right. Didn't actually get a number from them, but they announced a lot of things, big and small, from major new services to augmentations to existing services, all kinds of things. This year, some major themes were around machine learning, serverless, and more of an enterprise focus on enterprise transformations. Sometimes people kind of ask me, you know, with everything that's going on in AWS, and but there are a few ways right here. Here's the official AWS news blog, where you get the announcements direct from AWS. There's also Jeff Barr's blog. He's sort of their tech evangelist, has been for years. There's also some good podcasts. This is the logo of the AWS Morning Brief, put on by a very goofy guy named Corey Quinn. And he does the Morning Brief, which is kind of a recap of all the deluge of announcements you get from AWS, help kind of parse the changes that are coming down the pipe. And then there's Screaming in the Cloud, which is more of an interview-based kind of format where it's not just AWS, you'll get into Google Cloud and Azure and other cloud sort of oriented topics. Then there's also the official AWS podcast. So another way you can keep up is by doing just what you're doing, coming here and listening to sessions here at reInvent. You can see the schedule here. We've got more things coming next week, Tuesday, Wednesday, and Thursday. Come back for more topics, more food. We've got Dan and Amy presenting on Tuesday on DevOps and security topics. AI and machine learning from Tony on Wednesday, along with an interesting one from John Pazavilko about AWS Outpost, which is AWS' way of sort of taking some of the cloud and letting you have it on premises. And finally, we have James Smith and Tom Marinette on Thursday. James is going to talk about how we manage our sort of massive footprint of AWS and all the organizations that go along with that. So there's some interesting topics there. And then Tom is talking about media and streaming video content. Pay attention to that one. All right, a few quick hits. I'm going to run through some stuff. What happened? One interesting announcement is S3 access points. This is kind of a minor thing that's going to help us to better control how we give people access to S3. I can give Pete a different access than I can give Ben to the same bucket. Gives us a little bit more flexibility. Another quick hit. This is a picture of an outpost. What does it actually look like when you bring AWS hardware on premises? Kind of looks like a server rack. It's going to be very interesting to see what all you can do there. You obviously have to provision some stuff in advance. I understand they can do auto scaling, but it involves nano machines. John Foss will talk more about that. This is just a screenshot of something called SageMaker Studio. Machine learning was a big theme. SageMaker is Amazon's platform for doing machine learning in the cloud. And they've created a whole developer experience built around this IDE called SageMaker Studio. That is bound to come up in Tony's talk. This is an interesting one. A couple weeks back, I remember hearing about something called quantum supremacy. I can't think of which company did this, but it was some achievement in quantum computing, and I thought, wow, this is amazing. I wonder how long, I'm thinking to myself, just sort of jokingly, how long until I could just sort of order one of these up in the cloud? A week I waited. And I don't know what this is. This may be just a big goof from Amazon, but they've got something where you can spin up some quantum computing, but God only knows how much it costs or what you can do with it. But it is just kind of amazing to consider that this incredibly advanced technology is available to basically anyone in this room if you know what to do with it. All right, so I'm going to take a slightly deeper dive into some other topics here. I want to talk about something a little bit closer to home, Fargate Spot. I'm going to explain a little bit about what this is, but I'm an applications guy at heart. I've been a developer in my past life and more in the DevOps and deploying of applications. And one of the things that we think a lot about is how do we get applications out to our users and how do we make sure that they're robust, and stay up, and they're easy to deploy, and things like that. So let me explain a little bit about what this is. I have to go through a few things. I I don't know if you're familiar with the different purchasing options that you have in AWS, but it's the idea that the cloud is scalable and flexible, and so you sort of pay as you go. You're not buying servers, you're renting servers. So the most basic way to do that is to pay the on-demand price. You kind of just walk up, no questions asked. There's a certain price on a certain size of a virtual machine, with its CPU and its RAM and however much, graphics capability it has. They cost different things. There's one rate. You pay by the hour. So the price is the highest. It's the highest you can do because it's the most flexibility you can have. You just walk up and you buy it. There's another thing called reserved instances, which requires you to forecast out a little bit. You need to know, okay, I'm going to use this certain type of instance or this certain family of instance. I'm pretty sure that I'm going to use this, this whole year, or at least I'm going to have enough for work that I could say to Amazon, I'm going to buy this type of instance for a whole year or even 3 years, and they will give you cheaper prices if you pay it up front or pay that kind of installments. But it requires you to know what you're getting into. There's a new thing that I am ill-equipped to explain called cost savings plans. And it basically takes the idea of reserved instances and it makes it something that's hourly and it's a lot more flexible, and it looks like it requires a PhD, but I think it actually doesn't. We've got people that are pretty well versed in stuff.
We bought one last week.
See, James knows about it, so you can ask him next week. But really, it's the idea that if you can plan ahead a little bit more, you'll get the cost savings out of it. There's something else called the spot market. This is where you can get very deep discounts, 60, 70%, sometimes higher, at the cost of a little added complexity. So what even is this? Let's set the table. All right, if you're Amazon, you've got physical servers somewhere. We don't have to worry about physical servers, but of course they do. So you've got data centers just filled with racks of servers. And their business is selling them to us. Every time we spin up a VM, we take a little slice of one of those machines, we pay for it. But at any given time, they've got some that are just sitting there idle. They don't really turn off the machines because they're chopping them up into VMs. So they've got, when we say they've got space, what it maybe really means is 30% of this CPU is free, or 30% of this machine, or maybe they have blades on the rack that aren't in use. That's unused capacity. It's something they could sell and they're not selling it. So that's where the spot market comes in. We've got this unused capacity. We're paying for it anyway. How do we sell it to people? Well, we put a really big discount on it. And we as the buyer think it's slightly more complicated because we have to look at what the price is. The price of an instance on the spot market, that unused capacity, fluctuates. It can be very low. It can raise and lower with demand. So you can go into the EC2 console and you can see what the price history on the spot market for a certain instance type is. Because when you want to buy one, you don't just say, I'm going to buy one. You say, I'm going to bid. There's a certain price. In this graph, the on-demand price for the M4 large here has been, the on-demand price is 10 cents an hour. And you can see the fluctuation of the spot market by different zones. This one's, it's down to like 4 cents. Really a big discount. If you're running a bunch of these, you're running it for a long time. So maybe you put your bid sort of right there underneath. We're going to bid somewhere in between here, 7 cents. You get your instance for 7 cents an hour. That's 30% savings right at the top. And sometimes the gap is quite wide and you go very low. There's some caveats to this. That unused capacity, they might want it back. If the on-demand market has more demand, if people start paying that sort of on-demand price and they need that capacity back, they're going to yank the machine from you. Or if the price changes in such a way that your bid is now higher than what it would be on the on-demand market, your instance goes away. Poof, the instance is gone. And so you take a risk. You're getting a deep discount, but your instance may potentially go away. But don't worry, you get a warning. You get 2 minutes warning. So what use is this? Why would I ever want to use a server like this to give services to people that depend on me, applications I'm providing to campus, when the server could just go away at any time? Well, there are actually some really good use cases for this. If you're in, doing more research computing, there are parallel tasks that are really good for this, and actually highly available web applications. How can that be? Highly available servers that could go poof doesn't make sense. Well, there are things that you can do. Let's take a slight diversion and talk about containers. So when we deploy applications, a lot of times what we'll do is we just have a server, and we have our code that is the application, and we'll put it on the server. Containers say there's going to be a little bit of extra wrapper around that application. We're going to sort of create a small VM. And if you know containers, you know I'm sort of simplifying some things, but basically we isolate the app in something called a container and put it on the server. And then we can put it in multiple copies. You know, we can do the same thing without containers. We can load balance an application, put copy over here, copy over there, two different servers, load balance them together. That way we get double the capacity. If one goes down, the other one's still here. With containers, it's a similar concept. Each of these containers, or what's called a task, is distributed over multiple computers. So how we might deliver, oops. Oh yeah, I just wanted to point out here, the, the logo for Amazon ECS, Elastic Container Service. Now they've got this sort of sensible in line with their design identity thing, but it used to look a lot like, what does that look like? Does anybody? Yes. The space station from Deep Space Nine. I don't know why they got rid of it. So you take an application, you point your load balance, you point to what's called a service, which is the distribution of tasks. So one application might be a task that's on multiple machines. And in between here is something called the control plane. If you've heard of Kubernetes, that's one. ECS, the Elastic Container Service, is an alternative to Kubernetes before Amazon had Kubernetes capabilities. But all these things have to get distributed across actual virtual machines. And that control plane kind of helps you, put these tasks in places so they can be highly available. So what if we were to just say, hey, these are all spot instances now. Hey, we just saved a ton of money and everything's distributed and we're happy. But of course, they could go poof. So that doesn't work. And I want to point out also, you've got the management of this fleet. That's something that you've got to constantly be taking care of. Maybe it's an auto-scaling group or something like that. So you put this in an auto-scaling group. And there's a new feature that actually came out last year called mixed instance strategy. You create an auto-scaling group and you can say, okay, 2/3 of this I'm going to put on the spot. 1/3, I'm going to pay the on-demand price. I know it will never go away. I take priority over everybody. So in this case, 2/3 of your fleet could go away, but you still have guaranteed capacity. Your capacity might be diminished, but you're always going to be serving up a web application. And you get the price advantage of being on spot. So that's really nice. Also, anecdotally, people say, hey, spot instances don't actually disappear nearly as often as you might think. I've heard people say, I've got some that have been running for months, years even. So there's not necessarily that much volatility, and you can diminish the risk quite a bit by doing something like this. But you notice one thing, look at our report task 3 over here, it has ended up where it's only on a spot instance. So that application is at risk. In fact, you could replicate it because that's what you're supposed to do with containerized applications, but the control plane, ECS doesn't really understand what's going on down here. It's just putting things on servers. And so you could end up in a situation like this, where even if you're trying to scale out task 3, which is a web app in this case, it's still just only on spot instances. So it's at risk. That's where something called capacity providers comes in. This is where AWS lets us basically clue in the control plane to what's going on and say, all right, there's different types of instances here in this fleet. Make sure that you don't ever just put these all on spot. Put them some here and some there. And so we get that security of having the mixed fleet type for everybody. But I started this with Fargate. So you're probably wondering, when are we getting back to that? I did say this is your problem, managing that fleet of servers. Fargate takes that fleet of servers and replaces it with magic. It's a managed service now. And when we say managed service in AWS, the main thing you need to know is that something that was your responsibility is not anymore. It's Amazon's problem now. And really, that's the case. When you're on Fargate, you don't spin up servers. You just handle this stuff up here. You know about your containers, and you tell the ECS service, I've got these services, deploy them somewhere, and you don't see servers. It does it, and there are servers under the covers, but you never see it. It's magic. So what about Spot? Fargate Spot just announced. Basically, you can tell Fargate, take care of all my servers, and make them spot, and just do it for me. And as near as I can tell, I don't know this for sure, because I haven't been able to confirm it, I don't think you even have to do the bidding. I think you just say, hey, AWS, manage my servers and save me a lot of money, please. And he just does it. And you still have the things you have to worry about the mixed instance types, but you can do that because there are capacity providers in Fargate. And you can say, hey, Fargate, manage all those servers and make this percentage of them on demand and this percentage of them Fargate spot. It just does it. It's very cool. So,
is your, sorry to interrupt.
Yes.
Is your danger of losing spot instances in that case, Fargate, does that get mitigated or minimized at all?
Well, it's still subject to all the same risks that are inherent to spot. The thing that I'm less clear on and I need to find out more about is how it doesn't seem like you set a price. So how that price is set, of course, has an impact on when they get taken back. So it's something we would have to look into more. But the point, generally speaking, is that there is a lot of opportunity with spot for cost savings that we're not currently taking advantage of. And a lot of the risks that seem very risky when you read about spot, there are great ways to mitigate them. I mean, as long as you can distribute your task, and it's not just for containers even, as long as you can distribute across multiple instances, you can take a strategy like this and have part of your fleet be spot and just save a lot of money, especially if you're highly available already, so you have multiple instances. That's the thing to do. So ECS plus Fargate plus spot, there you go. All right. Just a brief note on that. The pricing is a little bit different between EC2 spot and Fargate spot. Slightly different concepts. So the savings are even greater if you're just on EC2, 90% versus 70%. Deep Composer. As I said, machine learning was a big theme of this conference. They really want to democratize machine learning. This is a slide I saw. They want to put it in the hands of every developer. It's not something that I personally know a whole lot about, but I'm very interested in it. And I just came out with something called Deep Composer, which is what I would call sort of a toy, a machine learning toy that joins a couple of other devices that have come out in recent years. There's the camera there called Deep Lens. There's the thing called Deep Racer, which is the car next to it. That's got a machine learning powered camera inside it, and they show you how to program it so you can make it drive itself around a track. They have competitions, and it's something that would be really fun to play around with. The last thing is this thing called Deep Composer. Deep Composer itself, as we'll see in a minute, is not going to exactly blow you away. I see it as really a vehicle for teaching a concept in machine learning that they introduced to me at any rate, called generative adversarial networks. We're going to dive into Brandon's extremely superficial understanding of machine learning right now. The idea in what's called a GAN is that you are trying to create something new. That's the idea of Deep Composer, is that you play a little bit of music, a melody line or something. It's going to try to augment it. In fact, let me skip ahead a little bit and show you this.
Deep Composer keyboard here. And what I'm going to try and do is play a simple melody. We'll send that melody up to the cloud and we'll generate a complete song. All right, no pressure. Here we go.
The keyboard here, I will say, unlike the other two devices, nothing at all special about this. There's no extra CPU chip in here or anything. It is just a MIDI keyboard. They sourced them from somewhere, slapped an AWS logo on them. You don't even have to use a keyboard for this. You can play on your actual computer. So what it's going to do...
Let's go ahead and send that to our rock generative model. In about less than a second, we'll go ahead and we'll generate all of the accompaniment. So here we have guitar, bass, synth, drums. Let's go ahead and have a listen.
I'm going to stop there because we have a ton of time left. But basically what this thing is doing is trying to generate musical accompaniment to the song. I've seen things like this. I have a phone on my iPod or my iPhone that will take, if I'm strumming along and try to put bass and drums underneath. I think this works quite different because this is based on machine learning. The idea in this adversarial network is you have two adversaries. You have a generator trying to generate music, and you have something called a discriminator, both different algorithms. This one is trying to create music. This one is trained to recognize if a bit of music is created by a human or not. Okay? This kind of distinguishing between kinds of things was something I saw a lot. I saw a presentation from one who said, I didn't know anything about machine learning, but I learned how to do what's called like a classification algorithm. This is sort of your entry-level hello world of machine learning, from what I understand. You take a data set. In this case, she had a bunch of pictures of shoes from some shoe retailer. They were already classified into things like sandals and heels and things like that. You feed all that into the machine learning algorithm, and you iterate over time. And between each one of these iterations, you kind of tell it how well did it do at taking the knowledge it gained from this pre-existing data set and applying it to a new picture. And it take what it knows, look at a picture of a completely different shoe, and decide, is that a boot, is that a heel, whatever. And in between each of those iterations, you give a little nudge. You were right in this area, not. And that's the sort of data science and machine learning that, where is that coming from? Anyway, so this kind of classification. So you've got the generator trying to create music, and you've got the discriminator telling it whether it's human-made or not. And the idea is that you pit these two things against each other until they converge, and the discriminator can't tell the difference. And so that's how it's generating that song there. I'm compelled to point out that based on this picture, I thought that looked a little familiar, that one too. This is precisely how Ultron was created. Did you remember this? Yeah, I don't know. It may come up in a second. Blue blob of computer stuff, orange blob of computer stuff. Yeah, see, it's very bad. Anyway, I don't have enough time for jokes right now, but it did look very familiar. Decomposer is very interesting. Unfortunately, I can't really demo it for you because it was in preview and they haven't released it yet. The one thing I found really fascinating with this is it doesn't actually do anything with the audio. It doesn't know anything about music theory or notes or timing or anything. It looks at stuff like this. This is a piano roll. This is what you get if you're playing with a MIDI instrument, any sort of musical generating bit of software. You can play on a real keyboard, and it will sort of paint the picture of what you play. And if you don't know how to play piano and you're creating this kind of music, you can use your mouse and you can, get piano into your composition that way. It's just a thing that musicians have been doing for a long time. Decomposer takes a picture like this and applies computer vision principles to it. It doesn't know about music, but it knows how these pictures ought to look. And it knows the kind of pictures that it can try to create that will match up to the one you do by playing Twinkle, Twinkle, or whatever you do. So in this demo, they open up a SageMaker application for us. And what you get is a Jupyter notebook. It's Python code. And you can see step-by-step how it went through. It took a sample of Bach. And it's trying to be able to augment any piano you play in the style of Bach, whatever. That's kind of ridiculous. But the idea is, it gets closer over time. And you can see that it pretty big. You can see, first iteration, there's a tune, and it helpfully kind of goes, bah, bah, bah. It's nonsense. But over time, it gets a little closer. By the time it's 1,500, 2,000, you actually see, amazingly, no idea how, it has managed to land on something that sounds like chords. There's some harmonic, cohesion to it. Really interesting stuff. You can find lots of fun, snarky takes on Decomposer online because it generally produces kind of bad sounding stuff. I managed to come up, they were sort of incentivizing us to publish something on SoundCloud because it's baked into their console. And now what you can't tell there, is that was Somewhere Over the Rainbow. And I actually pulled the piano part out and just left the other instruments. And so something new sounding, but it sounds like music. It doesn't sound like random noise. and that's, we're nowhere near saying, all right, we don't need people to be creative anymore. We have computers. We don't. That's not the point. The point of this to me is that it showcased this really interesting advance in machine learning, and sort of taught me a little bit about this technique that I didn't know about before. So I thought that was cool. One more quick hit about machine learning. They had this builder fair, which I thought was really cool. And the only thing I want to say about it is I met a couple of people who worked on this program right here they call Quinte. And they took that kind of classification algorithm, just like with the shoes, and they applied it to American Sign Language letters. And they came up with something that you could stand in front of a webcam, just any regular camera, and they said, make the, spell a word. Here's how you do it. Make the word. And it would recognize the patterns that you're making with your fingers, which has all kinds of interesting applications. So the only thing I really want to say about that, besides all this stuff is on GitHub, I actually was thinking about trying to build that for demonstration, but ran out of time. But if you're interested in machine learning, I am too, and I'm thinking about maybe trying to get something going. So if you are interested, come talk to me after. Maybe it's something that we can get some folks together to kind of dive into and do some stuff over lunch sometime. All right, that's that. Now we're going to transition to something quite different. And I will invite my colleague, Lisa MacKenzie, up to join.
I know.
We both sort of talked about how we'd be a little bit more comfortable if we could sing our way through this.
Yes. That's what the shades are for.
Right. So you guys have probably heard some talk about VDI initiatives, virtual desktop infrastructure, that are going on in OIT right now. I want to talk about that and talk about what AWS brings to the table. So this is application and desktop streaming. Lisa knows a whole lot about what we have been doing. This is not a terribly new concept, but there's some new developments that make it relevant to what we're doing today. What's the history of that?
Excellent. Because I have
Sure
to
thing.
I kind of threw this together because I was expecting to do this next spring, to be honest.
That's my fault.
So for those who don't know me,
Oh, yeah.
I can talk really loud, I promise, but now I can't see. I can't see what I'm talking about. So. Okay.
You got that as well.
Confidence screen. If I could just sing to you all, this would be so much easier. So for those who don't know me, my name is Lisa MacKenzie. I'm a systems administrator on the service and platform management team. Yes, my boss just gave me the awesome thumbs up for getting the acronym right. And we manage a lot of the enterprise applications on campus, all of them, most of them to be sure. So our story is that we were on Citrix. I'm sure you all were familiar with it. It was on-prem. We had it for many years, 5, 6, 7 years, I think. And then with our Cloud First initiative, we migrated to, we tested AppStream. It didn't quite work for us. 1.0 wasn't quite the solution we were looking for, so we migrated to Remote App. So we're serving up apps through Remote App. We tested workspaces. It's currently only in use at Mendoza, a very small pool. And anybody who knows information about this, you're welcome to jump in and give facts. I think there's some engineering, but I'm not quite sure. And I think cost was a pain point initially. It's a little more expensive than our traditional laptops and things like that. So we didn't go with workspaces at the time. You must have put the turbo machinery. I don't know about that.
I did, yeah. We can see.
Okay. Pain points. Okay, licensing was a huge pain point. Some apps are not intended to be multi-user, nor do they have any business being in a multi-tenant co-location. Thank you. The user experience for Remote App is poor. I wouldn't say poor at best for Windows users, different, very different from Citrix. For the Mac user, it's terrible. We have a lot of problems with that.
This was a direct quote yesterday. I think it was
Paul?
Paul. Yeah. He said, Remote Apps is bad for Mac users. He paused and said, it's also horrible for Windows users.
So I'm gonna defend the Windows user side, but I don't think it's horrible. I think it's a change management thing.
Yeah, what users is good?
It's just different. Yeah, it's just different. It's just different. So there was a change management component for the Windows users that we had to kind of work through. Again, like with Citrix, the customers didn't know, like, is it on my desktop? Is it in the remote farm? How do I put a PDF on my desktop? The basic challenges that we had with Citrix. And from what I understand, because I don't manage the Remote App farm, is that it takes multiple attempts to octify or get into your app, correct, Pete?
Correct.
He manages it, so everybody feel bad for Pete.
There's several hurdles you may have to jump to MFA into a Remote App. All right, so let's talk about what AWS brings to the table here. Oh yeah, so watched a leadership session, one of the sessions about end-user computing in general. And their general ethos here is give users anywhere, anytime access to company data and applications on their favorite device. It's important. Bring your own device. We do a whole lot of that here. And on the flip side, help IT be more secure, centralized management, automated things, reduce costs, and empower users.
Workspace. All right. So I went to reInvent as the representative from my team and for endpoint computing, just to kind of see what was out there. So I'm just going to just tell you that I don't manage workspaces, nor have I deployed it. So I'm just going to just tell you what I know about it. So it's a secure, desktop as a service. Can be provisioned with either Windows or Linux. Pay monthly or hourly or by the minute with Linux, which I thought was very cool. It's a big selling point when we went to reInvent. The big takeaway is that they can access their desktop from anywhere on any device. So your traditional laptop or desktop is effectively disposable. A lot of the places, and we'll talk about some of the examples later, a lot of big places are using Chromebooks and a Zero client, and they're disposable. It breaks, get them another one, $200, no problem. So your Mac Pro is kind of a thing of the past, and there's not the lugging around of equipment like we have today. Pack up our laptop, take it home, set it up, open it up, get on the VPN, do those things. That's a thing of the past with workspaces. It currently works with Active Directory and SCCM, which is a big plus for us.
I think you can go to the next one. So one of the other big offerings from AWS is called AppStream. Unlike workspaces, actually hit the next one there. It's application streaming. Of course, the idea with all this is it's like Netflix. You're getting a video stream back. Your clicks, you're typing, it's going over the internet to the remote service, whatever. And what comes back is the video. This is currently being tried in all kinds of ways for different applications. Google and Microsoft would both like this to be a thing for video games, and they're trying services right now. Google Stadia is a thing, and xCloud is coming soon. This is potentially the future of a lot of things. And it's only getting better. With AppStream, it's application streaming, so you don't see a desktop. You log in, you see applications specifically that are provisioned for you. So because you don't see a desktop, you're not really dealing with local storage. And your environments are transient. With workspaces, we kind of made a joke when we were talking about this yesterday. There are many like it, but this one is mine because it stays persistent. If you put something on the desktop as a file, it's going to be there the next day. With AppStream, you don't see that. It's supposed to be transient, which is a good thing and can be a very good thing for management. I mean, if you remember something like deep freeze, sometimes we want to just check those environments or set them back to where they were. With AppStream, every time you log in, it's a new experience, but you're using cloud storage, so the user, they've got the continuity, but from a management perspective, you don't have to worry about what users are doing to their environment over time. Just an example here from one of the sessions. This guy is using SolidWorks, very intensive graphics modeling application on an iPad. And because it's not running on his local machine on that iPad, you can do a lot of stuff that your machine might not really be capable of doing. So I alluded to this a little bit, but with AppStream, you build an image. You build an image kind of like we do today for labs. Put applications on the image, and you expose those applications to an end user. Clicks go out, video comes back. You see all those apps. But if you go to the next one, if you have more than one user, we're just going to kind of cookie cutter stamp that image, and you see all the same apps. The next slide is about something called Liquidware. Now, this is not an AWS service, but it's an AWS partner. It's somebody we've been talking to and trying to do a proof of concept around because they kind of blow that concept up. We'll talk in a minute about some of the pain points, but when you have a single image like that, you got to be worried about everybody that might use it. You want to make changes to it. All those 4 apps, they might be responsibility of different classes or faculty, and you got a regression test. You don't really want to touch things too much because other people are depending on it. With Liquidware, you get to decouple that a little bit. The apps don't live on a baked golden image. They live out somewhere like S3. And they can be kind of streamed in individually. VHD is virtual hard drive. It's almost like you have the application on a USB stick and you plug it into your machine. So we can have apps up here. We can have a very sort of thin, not complicated app stream image and send that out to different users, and they can get different applications. And the really exciting stuff about this is that how you divvy those up can be based on all kinds of things, like SAML assertions. So you can imagine a sort of a really future state. What if the student logs in and it's the SAML assertions that come with the login, something we can do through Okta, say what classes you're in. And we can look at those classes and say, you get this app and this app and this app. And you log off, this class is too hard, you drop it and add another one. You log back in AppStream, you get different apps, different classes. It is.
Hand off to Lisa, they're real exciting. So the benefits of CDI or VDI are clearly cost savings from the traditional infrastructure that we would have on-prem. The desktops are fully secure. Another thing we're talking about, the user experience, I believe, for most of VDI, or at least for workspaces, the root volume, right, and the user volume are backed up. So if you blow it away, you blow it away. The user doesn't know any different, and it's potentially very quick. Then, of course, we have secure remote access, and that kind of runs across the gamut for all of VDI. And these are some, I didn't put any notes in here, but these are just some quotes. I don't know where we got the direct
These are
quotes
fake
from.
quotes.
Oh, fake.
But then you can imagine them being spoken by someone.
Because they're going to use the lab at 2 o'clock in the morning, because that's what I would do as a student. So, some of our student experiences, faculty experience, and we can maybe talk about the lab image a little bit. The pain points there, I think, is important.
I mean, from the student perspective, one, you don't have to get up and go use the lab. The lab's full, doesn't matter. If the application your class requires needs Windows and you're a Mac user, that doesn't matter. Students are freed up quite a bit. I don't have to skip going home this weekend because I need to stay close to the lab to do my project for school. I can do it from wherever. There are a lot of really great stories for students around this, and we make their lives better. The things for faculty and for administrators, I feel like the liquidware story helps a lot because that gets to the management of it. When your apps are delivered individually like that, they're also isolated from each other, so you don't have to worry so much about regression testing. Now's where I'll tell a story about James. Well, James's experience is typical of many faculty members, which is that he's teaching. He's got software that needs to go on the lab images to teach his class. It's close to the beginning of the semester, and what he's told is, hey, when did you get this request in? Because we got to lock these images down a month or more in advance. If we got to do something to it now, we got a regression test. Who knows what it could affect? So when you bring something like liquidware, the faculty and administrative stories start to come into view as well.
Enough about the administrative side of it. Why not?
So one of the things that sort of occurred to me, and maybe to you, is this is not necessarily all that revolutionary. It's not new. We used Citrix 10, 12 years ago. What makes it interesting to talk about in 2020? One thing is, and I don't know if this is necessarily a new trend, but Catholic spending can't really keep up. What do I mean by that? I mean, dropping a boatload of money to refresh a lab is not necessarily going to get you what you need anymore. We have a very specific case in point right now with engineering and science computing. They have a lab they refreshed last year to the tune of 6 digits or something, a lot of money. The version of SolidWorks that they need to go to this year will not work. I don't know how that's possible, but it's already out of date 12 months later, and now they're up against the wall. So it's the flexibility the cloud offers, and you could scale those instance types up. Now they're more powerful, and you're off to the races. Another thing is that the management equation has changed, which I'll shift to the next slide for a second. When we're talking about Citrix back in the day, that was on premises, and I'm not going to get into what all those boxes say, but this is just a picture of how does the responsibility shift away from you as the IT professional and to the service provider when you go from on-premises VDI to something like Citrix, maybe we're going to host any EC2, we still have responsibility to keep things up, to more of a desktop as a service or full application streaming. It's just like with the Fargate example. We're shifting more things that would be our responsibility to someone else, which is great. Let's see, other things, go back one. So proximity is interesting. We worry a little bit about performance with these application streaming examples, but some of these presentations made the point like actually your performance can be better because one, you're already moving to the cloud, your data is big in the cloud, your data is in the cloud. Have your applications be in close proximity to the data. Also, you have people all over the world. We got some examples of companies that are global. We're global. We have our global gateways. we want to deploy applications to those folks. We want to do an app stream of workspaces. We can do it in the region that's closest to them because AWS has regions everywhere, so proximity plays. And endpoint security, we'll get to if we go into, let's see, one more. Yeah. Come back. When we do things like mobile device management to try to lock down, bring your own devices. If we're worried about what people are doing on their devices, it's maybe not secure. When you deliver applications in this way, you don't really have to worry so much about that because there's an additional sort of barrier. It's just, you're interacting with Netflix. You're not really crossing the barrier. And technology is catching up as well. Broadband is more places, and the streaming protocols are getting better and better. Amazon has their own streaming protocol. They've just come out for workspaces. It makes the experience a lot faster. Let's keep going. We'll go through that. Let's keep going.
Oh, you just glossed right over that whole licensing thing.
Yeah. I'm being cognizant of time. The thing with licensing is usually around whether they will allow you to virtualize an application. Most vendors can be talked into it if it's a factor at all. Most common thing is they just haven't thought about it.
But what we experienced when we went from Citrix to remote app is we had to ask those questions. So a lot of the apps that we use today have already been vetted for being virtualized. It's just something we would need to work on moving forward.
What about global implications with like laws, not just the licensing, but now they have different laws in different countries with
softwares?
We run into that with London. London has very different data laws, and we would just have to investigate how we're going to do it. But we can show an example, and one of the examples is Facebook. How's Facebook doing it? So they have a canned image or a workspace that they deploy to their entire global workforce. Everything is disposable, and they're using these zero clients. So they manage 20,000.
It's very big number.
They're doing everything workspaces with the zero client. So I'm sure we could partner with other global institutions and find out how they're getting around the data compliance. But I'm sure that we could work through it, and it would be something outside of the technology. But this was really popular for every session I went to. I think Carnival Cruise Lines was using it. Somebody else was using these zero clients. Very small. You can see the scale with the pen. This connects to your display, your Chromebook, whatever it is. And I believe it is encrypted pixels, right? So
yeah,
you can talk more about the technology.
Tiny computers. And very durable computers. There are really two flavors of this. One's called a thin client, which might run a flavor of an operating system. There's something called Windows Embedded. I didn't know was a thing, but it's a stripped down Windows. When you start doing that, your attack surface shrinks. And people used to say, well, Macs don't really get viruses because nobody pays attention. I don't know who's writing viruses that are unique to something like Windows Embedded or Windows IT. It's still Windows, so there's probably still a risk there. That's where you get to something called a zero client. Zero client has no operating system at all. It's designed to connect directly to the protocol. PC over IP is the thing that Workspaces uses, at least until they switch over to their new protocol. There's no operating systems, just firmware, and nothing to attack. There's no operating system that can get compromised. So that's really appealing to InfoSec folks. And these things last a long time.
Just real quick, moving back real quick to app stream versus workspaces. Do you envision a time where Amazon will deprecate one or the other?
I don't really at this moment. I mean, that'd be a good question to put to them, but it seems like they serve different audiences. I mean, even in our own sort of exploration into this on campus, we see there are some people that want the desktop for various reasons. I would want to challenge those folks, always to maybe see if they could make AppStream work first, just because it's simpler. But I think as long as those use cases are out there, they'll both be supported.
Do you need this here?
Keep on. Yeah.
Success stories.
Yeah.
Success stories. So I went to quite a few. A lot of the big ones were Facebook, GE, Carnival Cruise Lines, and I didn't go to Johnson & Johnson, so I'll let Brandon talk about that. But Facebook, what we talked about earlier, was really, really very interesting. They use the zero client. Again, like I said, workspaces across their global workforce. They have HA with the zero client. I didn't put this line in, the 4-time plan growth of workspaces. They're looking for more growth, is what it was sounding like. They use on-prem SCCM and AD. Like I spoke to before, they would back up the root volume and the user volume, so there's a problem, they blow it away. Workspaces back up in a few minutes. There's an interface for the connection manager, the Teradici connection manager, which manages all of them, all of the Xero clients. So if you need to do an update, I think it does it. I think they said within 5 minutes you can update your entire fleet, which is also very interesting. This is a snapshot of their architecture, which, as Brandon tells me, is very simple. So, having not built this, I don't know. Looks like it's very simple. And Carnival Cruise Lines, what I liked, some of the themes that I heard, and especially with Carnival, was they did a skunk works project for workspaces, and they liked it so much and it went so well that in 30 days they deployed it to production. So they went from their reservation agents having, a laptop they had to take home and had to be secure and VPN and all that, to thin clients, Chromebooks, and full production in 30 days. So the thing that I heard over and over again is, don't fear the initial cost. There's always a cost investment. Where they saw almost immediate cost savings was from the support cases. Their support went almost to zero. And most of the things were like, something's happened in my workspace, they blow it away, it comes back up in 5 minutes, the reservation agent's back online. And they have a very small time period to make their money. I think they said like 3 months out of the year is when they make all of their money for the year. So these people can't be down. And then they got around PCI compliance too by going through a third party. So got lots of cool things. Again, things can be done quickly, get it into production. It doesn't have to be a big deal. They weren't expecting to use it. It just worked so well. There they went. So GE, this one was a little more complicated for me. They use AppStream, and they scaled it for 6 time zones because they're all over the world. And they were using these legacy applications to fine-tune turbines and the giant ones you see, the wind turbines. And they needed to centralize them and deploy them, so they use AppStream 2.0. And then I think the important thing that you wanted to talk about was how they allow their application teams to manage their apps.
There are a couple of interesting things about this. 2 things jumped out to me that I think are maybe screenshot on the next couple of slides. But one is that, one of the things we kind of worry about is the potential for unbounded access here. These things like these 2, they're paid by the hour. What keeps someone from just kind of keeping these things all the time on and racking up charges? How do we actually know how we should set our scaling policies? Because you have to, like with auto scaling, say how you're going to spin up the app stream so that one is there when someone needs to get in. So they looked very closely at their usage, and they had the actual graphs of how of how their usage for these applications changed over time, which let them set really intelligent scaling policies so they tracked how people were actually using these things. They never spent more than they wanted to on delivering these apps. The next slide I think is also interesting because they opened up their workflow so that it didn't just have to be the most technical infrastructure kind of people working on deploying these app stream images. They could allow someone who's an app administrator in their terms, that for us that would probably be one and the same type of person, but for them it was maybe a less technical role. They could have a person who doesn't really know about AWS package up an application and deploy it to users without really having to involve everybody down the stack.
I'll leave this one with you because I did not
Sure. So Johnson & Johnson, they also had a really big workspaces deployment. The journey here is that they started trying to do it on their own early on. They tried to partner with somebody to do it, and eventually came to workspaces. This is just going to be a lot easier if we work with AWS. And not all the features they wanted were there at the beginning. This is the beginning of workspaces. They said we partnered with AWS. We told them what we needed. They were very responsive to features and enhancements that we needed to make this really work for our business. You can see just some of the numbers here. They're just massive, 32,000 workspaces deployments. Their churn of employees is 3,000 per month. And it made me wonder, what is our churn of employees? How much time do we spend setting up new endpoint computing environments for people that come on board as new staff or active members? And what could we save if we didn't have to do it? And they're looking to expand. So you see a few of the use cases that they decided to get into, and if we go on to the next slide. And I think you do the next one. They're saving money as well. So what's next? I think that's the final slide. We are in the middle of evaluating all this stuff right now. We've done our pilot with AppStream for students in engineering. We are working with Liquidware right now to prove that concept out. We've got a very detailed report that Chad's already put together about where we stand right now in terms of opportunity. We've got folks in engineering and science computing looking at ways to maybe do this on premises, but generally speaking, we see there are advantages to going to a fully managed service in fact. So there's a lot of talk right now about how can we really make this something that's transformational for the university. And we're in the process, and it's going places.
And one of the common themes that I heard while I was at reInvent was many institutions, not just higher ed, went from Citrix to remote app and are desperately looking to jump to something else, be it workspaces or AppStream. Almost everybody in every session had that same problem. And another common theme was not to fear that initial cost investment. You need to look beyond that. And yes, there's always going to be the cost investment, but the return might be in the reduction of support hours. And the other thing is, think outside the box. Like, we're very traditional, like you're gonna get your CPU machine and this is what you're gonna have for 4 years. We really, the practice of the disposable Chromebook and you can get your access for your workspace anywhere is really kind of the future of the model. And I think it's really important to us, especially now that we have more work-life balance, where people are working from home. You can, like I said earlier, you can take your laptop from your office and move it to your home office and get it all set up. I mean, that just makes it so much easier. If I have my iPad, I can launch it on my iPad and do what I need to do. And I think it would add a lot of flexibility to our work environment. And I think it would be a better experience for our customers who are not having the best experience with remote.
Yeah. If we can make this work well, it has a lot of really interesting applications. I mean, just take a look at labs. Labs wouldn't go away, but the way that they're formatted could change. Maybe they become more collaborative spaces. We've heard that people really like hooking up to the additional monitors. Maybe they don't really need the machine that's sitting underneath the monitor. Some people just roll their laptop up and plug in an extra monitor, and that's what they want the lab for. I think we have an opportunity to change the way that we spin in hardware, to change the way that we think about delivering applications and collaboration and all kinds of things. So it's really exciting. Thank you. Thanks, Lisa.
So they handle maintenance and all that. And what about upgrading like major versions of operating systems? They would handle that, or?
So you build up a base image. So what you would be doing is you wouldn't really be doing the patching, but like a major version, you would want to redeploy on the next version of your server.
Okay. So kind of like you would take the application, kind of like a container, and just put it onto the new EC2 instance, basically.
Yeah, the Liquidor model is very container-esque.
Okay. That's pretty cool.
That's my point. If we go with a thin client or a zero client topology, does that mean every student and every staff member gets a thin client so that they can interface with whatever it is that we're using?
Well,
Our staff.
yeah, it's a massive change management question, and it's not something that anybody takes.
The kid who's got to do a lab at 2 a.m. in the morning.
Yeah.
And the lab's closed or not.
Oh yeah. So, I hope that it would maybe didn't make it clear. Thin clients, zero clients, those are good for where you already have hardware deployed, but you can do this stuff through the browser. Use your existing hardware. So when we talk about some of those things, we're thinking about labs, we're thinking about, maybe administrative uses, but all of that is really a matter of partnering with folks on campus and doing what makes the most sense for those constituents.
So that is not applicable for an offsite use, the zero.
Potentially. I mean, that's how Facebook did their deployment. Their big case was we've got contractors everywhere. We don't even consider them actual Facebook employees, but we've got to get them into our applications. So here's a way that we can give them something super standardized. There's no variation in configuration, and it connects to our stuff securely, and it's cheap, and that's how they do it.
With no hardware.
With the zero clients.
With the zero clients,
Yeah.
so they are dishing out the zero clients to all of their people. So
yeah.
Were they dishing out the zero clients to those contractors in other countries, or were they using their own computers?
They were actually sending them to their contractors.
So just hypothetically, somebody loses one or one gets stolen. What then? Is that a
All it knows
Is that
to do
breach?
is all it knows how to do is connect. Like
Yeah.
it only knows how to connect.
You still authenticate. It's doing like Octa or 80 or something.
So going
Someone
back to my
loses it.
original question, every student, every staff member would have to have a zero client or a thin client assigned to them, correct? That they could throw in their back.
Yeah, I'm hesitant to jump to that because that's such a big leap of where we are
No
today.
question,
But
that's an open-ended.
you know,
question.
it's
I think the idea is that it offers flexibility. Right?
Yeah.
Just like so many of our students in school now have the Chromebooks, right? Like that's, you know, a device that gives you, you know, keyboard and browser type stuff. I mean, that's essentially what this means, is that all the processing and all the compute is in the cloud, not on the physical machine.
Right.
For things where people are more stationary, right? They have, you know, like they go to a lab or to a location, then the TID client plus, you know, whatever peripherals are needed is the max that needed to be invested in order to make that a workable workstation. And it's, you have options. So like there's the thin client, there's the zero client, there's the Chromebook, there's, you know, the low, you know, the laptop that doesn't have all of the beefed up stuff. You don't need to do the work on the laptop, it's done in the cloud. It just says this swath of options is now available based on what your needs are.
You're just getting an input.
Chad, anything to add? You've been.
Yeah, so like CWP, we get $1,100. This was the last year for 4 years.
Mhm.
On average, we're spending about $1,500 per device across the university. And so you could, instead of buying a $1,500 thing, or you know, a lot of us have MacBook or whatever, like my machine was $2,200. And I was able to do stuff in AppStream in our demos that was outperforming my brand new top of the line MacBook Pro, because Amazon's got way more computing power than whatever I'm going to fit into a laptop. So the idea that maybe instead of $1,500 average, you bring that average down to, you know, something a little lower, and you have a machine that frankly might outlast the 4-year cycle that we have today. Because I'm not worried about this having to run some piece of software in 3 or 4 years. So, but the CWP stuff is an opportunity. There's a big gap between where we are and where we would need to be to get to that point. I'm not at a point where I would want to give up my machine to do that, but I could see that in the future.
We gotta make the apps work.
What's that?
We gotta make the apps
All right.
work.
Yeah, you gotta get
Meet
it
all the
over.
needs before we worry about what peripherals you're using to get there.
So, so we can keep talking. I want to kind of close out the Zoom for people. If you're still remote, thank you for joining us. Thank you to everybody here in the room. Appreciate it. Come back next week.